Hello Ashley, you come for your train set, have you?
For many, it all starts with the train set.
There it is then, Flying Scotsman.
Excellent.
Good. Right.
Some start young, while to others, time of life is no barrier to beginning the hobby of a lifetime.
My wife gave me a Hornby 00 train set as a Christmas present. I mean, I was absolutely knocked out. I'd never expected anything like that. And, well, it was the best present I've ever had.
There.
With today's off-the-shelf products, even a train set is not so much a toy as a precision piece of engineering. But there is, of course, a world of difference between a train set and a model railway. People have been building model railways for over 100 years, but unlike the past, today everything you need can be readily purchased. Almost every class of locomotive and every type of carriage or wagon ever built is available in model form. And every detail is catered for too, from buildings and scenic features right down to miniature people and road vehicles. The wealth of ready-made items on the market has reached a point where the question isn't whether you can buy a wheelie bin, but what kind you choose, open or closed. Although it's never been easier to start out, you may feel overwhelmed at the idea of having a go yourself. The fact is that the basic skills are easy to learn, but where do you begin? Initially, there's plenty of fun to be had just watching the trains go round, but when it's time to stop, everything has to be packed back in the box. So the first step is to get the railway off the floor. The trouble is that a permanent base, or baseboard as we call it, takes up space. So where can you put it? A loft can make an ideal home for a railway, but don't overlook the cost of providing access, floorboarding, insulation, ventilation, and an electricity supply. For those of us with more limited resources, Peakorama at Beer in Devon offers a number of good ideas. Alongside the pleasure gardens and miniature railway rides, there is a permanent exhibition which shows how everybody has space for a model railway. This layout is designed to fit into a garden shed, but could just as easily go into a garage. By building a baseboard that folds up against the wall, you can still park your car there. Whilst a spare room would be ideal, if you don't have one, why not put the railway on a shelf around a bedroom or living room? Done tastefully, it can be an attractive feature. And here's proof that if you've got room for a fish tank, you've got room for a model railway, especially if you put the railway in the tank. The fact is that just about everybody has space for a model railway if they really think about it. But how best to use that space? There are a few basics that it's best to know at the outset. The first of these is scale. This model is 4mm scale. 4mm on the model equals 1 foot on the real thing, a ratio of 1 to 76. It's a strange combination of metric and imperial, but that's just the way things have grown up. 4mm scale is the most popular scale in use today. Another basic is gauge. Gauge refers to the distance between the rails. Here the distance is 16.5mm, which is commonly called OO gauge in the UK, or HO gauge everywhere else. So here we have a 4mm scale OO gauge locomotive. This second loco is roughly twice as big. It's built to a scale of 7mm to the foot. It runs on O gauge track, which is about twice as wide as OO. This much smaller loco is only half the size of the first engine, being just over 2mm to the foot in scale. It runs on N gauge track, N standing for the 9mm distance between the rails. Of the many scales and gauges, these are the most popular. They can be combined in different ways. Sometimes, such as with industrial railways, limited space and finance dictated the use of narrower tracks. By mixing different scales and gauges, modellers can reproduce this. For example, a narrow gauge layout could be built by running 7mm scale models on 16.5mm gauge track. As a beginner, it's best to stick with 4mm scale OO gauge or N gauge, for which there is a good supply of ready-to-run products. N gauge is ideal if space is limited, as it occupies only 1/4 of the area of an equivalent OO gauge layout. But it has more to offer than just space saving. This layout occupies an area that is more than adequate to accommodate an OO gauge layout, but by using N gauge, the builders have managed to leave more room for scenery, creating a more open look. They are also able to run longer trains. But there are two main disadvantages to N gauge compared with OO. Making models and buildings on a smaller scale can be trickier, and some people find the tiny models difficult to see and admire. Scale and gauge are the first considerations when designing your layout, but they're not the only factors. A key element of layout design is the configuration, which may depend on the space you have available or personal preference. The simplest configuration is circular on a solid baseboard. The basic oval can be embellished with sidings, and through the strategic placing of bridges and tunnels, you can give the impression that the trains are actually going somewhere. A hole, or operating well, goes one step further in removing the impression that the trains are chasing their own tails. Alternatively, there is the end-to-end layout, where trains travel from A to B and vice versa. Such a design can be along one wall, L-shaped round 2 walls, or even U-shaped round 3 walls. Although journey times will be short, the end-to-end design permits the layout to be operated much more like the real thing. End-to-end layouts come in 3 forms. A station located at either end of the layout with trains running between them. Station to fiddle yard, in which trains travel from a station at one end into a series of sidings at the other. These sidings are called a fiddle yard because they are regarded as off-stage, so the operator can manhandle the rolling stock. Often they're hidden from public view and are entered and left under a tunnel or road bridge, which masks the entrance. End-to-end layouts can also be fiddle yard to fiddle yard, whereby trains pass from one off-stage area to another as they move through a scene such as a station on the way. Fiddle yards can also be incorporated into circular designs to enhance operational interest. Once you've decided on the configuration, you'll need a track plan. There are several track plan books on the market, and further ideas can be obtained from the Plan of the Month featured in each edition of Railway Modeller magazine. You should be aware of a few basic principles. Curves in OO gauge should have a radius of no less than 381mm or 15 inches. In N gauge, the minimum radius is 229mm or 9 inches. Tighter curves will spoil the appearance and cause trains to derail. Run-round loops also need thought. These enable locos to arrive with a train, be uncoupled, and then run forward onto the loco release head shunt. The loco can then depart for the shed or connect to the other end of the train. There are 2 crucial design factors. Firstly, make sure that the run-round loop is long enough to accommodate the longest train you're likely to run. Secondly, the loco release head shunt must be of sufficient length for your largest loco to clear the points. The same applies to goods sidings. The head shunt must be long enough to allow wagons to be moved back and forth between the sidings during shunting. Layout design must also allow for the length of point work, which in 00 gauge is at least 175 mm or 7 inches. There comes a time when you want to give up planning and start building. But there's no sense in laying out good money only to find that the theory didn't work after all. Much better to try out everything full size before you engage your wallet. Draw out your track plan on an old roll of wallpaper laid out to the shape and size of your proposed baseboard. Pico turnout and crossing plan sheets, identical in size and radius to the corresponding item in the Pico range, will aid accuracy. Cutting up paper templates is cheaper than buying track you might end up not needing. Next we're going to build a layout using Plan 3 in the Pico Set Track Plan Book, which we've adapted to include the largest radius set track curves and an operating well. Our first task is to build the baseboard. It's tempting to rush the baseboard in order to get onto the creative work. But bad baseboards mean constant derailments and jerky running, so time invested now will pay off later. For rigidity, it's essential to mount the baseboard top on a framework. Ensure that no more than 300 mm, about a foot, is allowed between the bracing. It's best to begin by constructing the outer frame. As simple butt joints are used throughout, you don't need any special carpentry skills. Like the outer framework, the cross members are made from 50 by 25 mm timber, or 2 by 1 if you like to think in inches. Drill a hole in the centre of each cross member to allow wiring to pass through later on. It's much easier to do this now than after the baseboard has been assembled. One reason you can get away with butt joints is that the framework is glued as well as screwed. A standard PVA wood glue is all you need, and once this has been applied, the cross member can be placed in position. Now, using a 3 mm drill bit, clearance holes are made for the 2 screws used on each butt joint. These holes will help the screws go in straight without splitting the timber. Use of a countersinking bit ensures that when the screws are inserted, they will not protrude above the surface of the timber. Number 8 screws should be used, and the clearance holes will guide them accurately into place. Sometimes people are tempted to take shortcuts, such as dispensing with the cross members and relying on the baseboard top for rigidity. Don't fall into this trap. Without bracing, the top surface will warp and reliable running will be out of the question. The cross members are essential to making the framework rigid in its own right. Now it's time to add the baseboard top. In readiness for this, you should first apply wood glue to the surface of the framework. The top itself is cut from a solid sheet of board. The layout we're building requires a baseboard area of 214 by 122 centimetres, or 7 feet by 4 feet if you prefer. Most timber merchants will cut the board to size for you, although you may have to cut the access hole yourself. With the board in position, it can now be tacked to the framework. You can use plywood, MDF or chipboard, but by far the best material for the surface is Sandila. You can easily push pins into it and it absorbs sound. To finish off the baseboard surface, apply a coat of matte emulsion, which acts as a sealant and gives added strength. The finished baseboard top will of course need to be raised off the floor. You can fix the baseboard to a wooden batten along a wall with supporting legs at the front. Or you could add storage space by sitting the front edges of the baseboard on shelves built from a flat pack. Alternatively, a freestanding arrangement allows the layout to be moved if you're prepared to construct some legs. First, though, there is the question of baseboard height. Viewed from above, a layout tends to lose some of its realism. When seen at eye level, the effect is far more satisfying. Therefore, an ideal height is 145 centimetres or 4 foot 10. However, if you intend to have a large solid baseboard with no access hole, the baseboard height will have to be reduced so that you're able to reach across it. As before, 50mm by 25mm timber and simple butt joints can be used for the legs. As well as screwing the legs to the baseboard framework, you'll need to add bracing further down to keep them rigid. After the baseboard, the next task is track work. With train sets, the track comes in short sections with pre-formed curves. Rail joiners are already fitted, so you just push the sections together and within minutes the trains can be running. Pico Setrack follows identical principles. To allow you a little more variety in layout design, curves are available in 3 different fixed radii. Setrack is good for beginners because the universal rails allow you to run any rolling stock on it. Also, all the points, or turnouts as they're known, are internally wired. They are what is known as insulfrog turnouts, which means that the frog, the point where the rails cross, is insulated, avoiding the need for any additional wiring. Most people start off using Setrack until they've gained enough experience to progress to flexible track. We'll look at flexible track in more detail later, but for our first layout, we'll stick to Setrack. First, we mark the position of the trackwork on the baseboard. The track is loose assembled and its position traced using a fibre tip pen. The track should then be removed so that the ballast can be added. On real railways, ballast consists of stones packed under and between the sleepers to form a stable track bed. On our model, we'll represent this using Pico foam inlay. Granular ballast can be used, but it's more involved, and an example will be shown later. The inlay is cut with a sharp knife to marry up with the adjacent section of track. Then a small amount of impact adhesive is applied to the slots in the inlay in which the track will sit. The track can now be inserted in the inlay using a little pressure to ensure a snug fit. When joining Setrack, rest your wrists flat on the baseboard. Waggling the track in mid-air will distort the joiners and cause bad electrical connections. Proprietary track pins can be used to fully secure the track, but don't drive the pins in too deeply or the foam will squeeze up and stop the track from being level. Individual foam inlays are available for turnouts and diamond crossings, and these can be laid at this stage if you intend to operate the turnouts by hand. If you want to operate them electrically, there's something else you'll need to do first, which brings us to wiring the layout. Movement is an essential ingredient of a model railway. Achieving it means getting electricity to where it's needed, when it's needed. Some find this basic requirement daunting, but there really is nothing at all complicated about it. Most train sets are supplied with the equipment to make the trains run. A transformer to convert mains current to 12 volts DC, a controller to control the speed and direction of the trains, 2 lengths of wire and a means of connecting the wires so that each is in contact with a different rail. Whenever one of the wires is disconnected, the trains will stop. This simple fact is the guiding principle behind wiring the layout. It applies every time you operate an insulfrog turnout, and if you understand why this is so, you will have found the key to wiring the layout. Each blade acts as an electrical switch. When the turnout is set towards track A, current is fed to both rails in this direction. But one of the rails on track B is deprived of current, so any loco on this track will not move because it is electrically isolated. Switch the turnout to track B and both rails become live. Any loco on this track will move, but the one on track A is now isolated. This is very useful if we want to operate our layout using more than one loco, but there is a problem to beware of. If the two wires are connected on track A, the loco can run up and down this length, but if we switch the turnout to send it back up track B, we find that the loco becomes electrically isolated. Similarly, connect the wires on track B and this part of the layout will work fine, but when the turnout is switched to track A, one of the rails is denied current and so the loco won't run. To avoid such problems, connect the wires at the leading end of the turnout, often referred to as the toe. Now the loco can be run along either track. As most layouts have more than one turnout, you need to identify the one that is the source feed to all the others, and then ensure that the wires are connected to the leading edge of this turnout. Our layout's track arrangement suggests that we need a separate controller for each oval, with the power wires connected at the leading end of each main turnout. Both ovals themselves will always have current. If we switch the turnout on the inner oval to send the loco into the head shunt, this will then also receive current. But what if the turnout on the head shunt is set towards the sidings? The sidings remain isolated, but the head shunt is now also denied current. Clearly we need a third power feed on the head shunt. We could install a third controller. This would permit 3 trains to be run at the same time, one shunting in the sidings and the others running round the 2 main circuits. But as the current from different controllers must never be allowed to mix, we would need to add a section break between them, so that the controllers feeding the head shunt and the inner oval are electrically isolated from each other. Section breaks are made by replacing the normal metal rail joiners with insulated plastic joiners, which are readily available from Pico. Locos will still be able to pass between the 2 sections simply by making sure that the 2 controllers are turned to the same position. A similar principle applies if you want to hold more than one locomotive or train in a siding. An electrical brake is made by inserting an insulated rail joiner in one rail. A separate wire is connected to the rail on either side of the brake, and the 2 wires are fed to a switch. When the switch is on, it allows current to pass across the gap so that a loco can move into the isolating section. When the switch is off, the current flow is broken. Any loco held in the isolating section will then be unable to move, while a second loco can be run on the section of track that is still receiving current. Section breaks and switches can also be used to make one controller operate different sections of the layout at different times. So if you don't want to run trains on the inner loop and shunt the sidings at the same time, the third controller on our layout can be dispensed with. As a result, all power feeds remain exactly where they were before, but instead of having separate controllers for the inner loop and sidings, both are connected to controller number 2 via 2 switches. Now we can power the inner oval but isolate the head shunt and sidings. Or we can isolate the inner oval and divert controller number 2 to the head shunt and sidings. What about turnouts? Pico point motors fit to the underside of turnouts to avoid spoiling the appearance of the layout. They come with full instructions and are fitted by simple tags prior to laying the track. To accommodate the motor, you will need to cut a rectangular hole in the baseboard. This is best done using a knife, but you'll need to ensure that the blade is sharp. Check that the motor operates correctly under power before installing the turnout on the layout. Nothing is more annoying than discovering a fault once the track has been laid and ballasted. The wires running from point motors can be connected at the other end to a variety of devices to permit operation. For example, Pico toggle switches are supplied with different colour levers to aid identification and can be fitted into a console unit that is available specifically to go with them. Another option is studs, mounted on a plan of the layout with an electrical probe being used to set the road as it makes contact. The electrical supply for point motors and some other accessories is taken from a 16-volt auxiliary output on the controller. Most controllers have this facility. But how do you power numerous sets of turnouts from a single supply? The switches for turnouts or signals are wired in parallel from a single wire that is run from one of the controller's auxiliary connections and feeds each switch. Two wires then connect each switch to the point motor. A common return wire connects all the point motors together and carries the current back to the controller's second auxiliary connection. All electrical wires are best laid to run underneath the baseboard. This is where the holes we cut into the bracing when building the baseboard start to prove invaluable. A neat and secure method of connecting wires is the so-called chocolate block connector, stocked by most model shops or electrical stores. An alternative to conventional wiring is digital command control, or DCC. With DCC, each loco is fitted with a chip and can be independently selected and operated from a central control unit. So, numerous engines can be run on the same track without the need for any wiring other than the main power feed.
Well, it's a system that gives you independent control of locomotives, and the actual function all works with the aid of a command station which feeds the hand control system, which feeds the signal back to the decoder fitted into the locomotive. Well, the decoder has a series of functions, some of which you can program themselves, others with independent coloured wires on there which will turn on the different functions in the locomotive, i.e. you can turn on the whistle, you can turn on the lights, or you can turn on sound systems, or any extra functions that you want to program into the locomotive yourself. The latest things are radio systems which eliminate even more wiring, which means you can pick up the control unit, literally walk around the room and control your locomotives from any position you need to.
Now our layout is fully operational, it's time to move on to the scenery. Scenery refers to all the decorative aspects of the layout, excluding buildings and accessories. It brings a layout to life, and we're going to show you some of the main techniques which, in time, you can refine and adapt to suit your own needs. Creating scenery can be messy, so cover all your track work with paper and tape it into place. Failure to protect the rails could result in unreliable running later on. This is also a good time to add a board to the back of the layout. Cut from a sheet of MDF or similar material, it's simply screwed in place and will later be used as a mounting for a back scene. Our layout still looks rather bare, but the scenery will soon change that. First, let's provide some ground cover. Texture is just as important as colour in achieving a believable appearance, and scenic mats, bought off a shelf, are an easy solution. Available in a variety of colours, you cut them to the desired shape and then glue them to the baseboard with PVA wood glue. You can also adapt this principle by using materials such as dyed lint or carpet underlay. Moving above ground level, most scenery requires a sub-base, a shell, and a surface finish. To create the sub-base, many people use 50mm thick polystyrene. Easily cut with a kitchen knife, it lends itself to being carved into any desired shape. It's also light in weight and can be cheaply obtained from discarded packaging. The sheets are secured in place using PVA wood glue and built up in layers. Another type of subbase is wire netting, obtainable from any garden centre. To support the netting, we are using a leftover piece of polystyrene. The ends of the wire are bent so that the mesh will push fit into position. Wire mesh is particularly suitable for covering large areas quickly, where it can be supported on formers made from offcuts of sundealer. Strong and rigid, they also permit the wire netting to be stapled down. Strips of card, which can be cut from old boxes, can also be used as a subbase. The card is pinned to the baseboard and attached to the wire mesh, but for larger areas you could make formers from sundealer. Note how the card is interweaved and then glued for structural strength. To create the hard shell, there are, again, various methods, all of which can be combined with the different types of subbases. You can use a domestic crack filler, such as polyfiller. Mixed to a creamy paste consistency, it is applied with a palette knife. Here, the polyfiller is being used to build subtle contours over the polystyrene layers of the subbase. Once the plaster has been applied, you can obtain a smooth finish using a wet paintbrush. A faster and less messy way of creating a hard shell is Pico landform. A plaster impregnated cloth, you simply dip it in water, then lay it over the subbase. It can be used with any of the subbases we have looked at. Flexible and easy to work, it eventually dries hard. It has the lightness and strength of plaster, but is easier to use. For a smooth surface, you can add a thin coating of polyfiller over the landform, but you won't have to worry about using the plaster to create the basic shape of the shell. A coat of neutral emulsion completes the hard shell by acting as a sealant. Now we're ready to add the surface finish. Various grades and colours of scatter materials are available. You can even use them to create ground cover. It's slower than using textured mats, but the results are more subtle. To give the scatter materials something to adhere to, apply a 50-50 solution of PVA wood glue and water using a small decorator's brush. To ensure good coverage, work on a small area at a time. Next, starting with a fine grade, you sprinkle the scatter material over the area. Remember, in the real world, the landscape comprises a host of different colours and textures. The more you blend different grades and colours of scatter material, the more realistic the result. You can also create more specialised scenic effects. To make a rocky surface, natural substances such as bark or stone are readily available from model shops. They are attached to the scenic shell using plaster. The rocky appearance that results can, if required, be further transformed through painting. Cooking foil cut into squares is another way to create a rocky surface. First, you roll it up into a tight ball. When you open it out, the irregularities leave you with a very effective mould. Apply a thick layer of plaster, or plaster of Paris for quicker drying, preferably to the shiny side of the foil for best results. When the foil is pushed up gently against the wet plaster face, its irregular contours are impressed on the surface. When the plaster has set, remove the foil and what remains is a highly convincing rock face. This can later be enhanced through painting. Subtle use of colour and texture can also be applied to building a roadway. A thin layer of plaster is worked in to develop the surface, which can even include a camber. Judicious use of shading when you paint the road can create effects such as tyre marks, increasing the overall subtlety of the model. Scatter materials can be used to add nice little touches, such as weeds growing by the roadside. One detail that worries many beginners is water. Proprietary products like these from Green Scene are available from most model shops. To create a river, for example, you first mark out the shape, then build up the bank using polystyrene and plaster or landform in much the same way as shown earlier. A coat of emulsion seals the surface, and the riverbed is built up using paints and scatter materials. Scatter materials are again used to simulate foliage on the riverbank using the same techniques we looked at earlier. To make the water, the contents of the two bottles are mixed and stirred. The next step couldn't be easier. All you have to do is pour the mixture over your riverbed. Once it has dried, you have a permanent wet look. But what about flowing water? That's where the third bottle comes in. You simply paint the fluid onto your water surface and work it in with a brush. Alternatively, you can create your own water effects. Try painting a sheet of perspex with a blend of colours. When you turn it over, you have a water surface that can be incorporated into the layout. The basic landscape can be brought to life through finishing touches such as fencing, bushes and shrubs, and of course trees. The railway fence can be purchased ready-made. Just drill small holes for the posts and slot your fence into position. Pico flexible fencing, for example, is designed so that the poles are always vertical, even when mounted on an incline. For bushes and shrubs, ready-dyed dried lichen is available from model shops. You simply tease the lichen into bush-sized clumps and glue it in place. A good source of trees is the K&M range. These are fixed in position by drilling a small hole in the plaster and applying some impact adhesive to the stem. The hole ensures that the trees will withstand accidental knocking. If you wish, you can have a go at making your own trees. Forest in a Box from Green Scene uses a naturally occurring plant material commonly called sea foam. You dip the sea foam pieces in a well-diluted adhesive such as PVA and then sprinkle it with coarse-grade scatter material. Finally, give the model a tap to remove any surplus material. Here's the final effect, with trees and bushes straddling the bank of the river we made earlier. Most layouts are created using the kind of techniques we've been looking at, so landscape modelling really is within anyone's capabilities. Next, we're going to add some buildings to the layout. Buildings make an important contribution to the character of a layout, and since most layouts include at least one station, let's begin here. Platforms are available in the Trackwork range as easy-to-assemble plastic kits. They're ideal to begin with, since they'll enable you to progress quickly. Only a limited amount of cutting is required before all the components are ready for assembly. Full instructions are provided, although it's hard to go wrong because everything snap fits into position. The assembled kit holds together well on its own, but it's a good idea to apply plastic weld to give the joints extra strength. The kits include self-adhesive brick paper to complete the effect. As the individual units snap together, you can build platforms of any length you require. Station buildings are also readily available as kits, although you could make your own. Many modelers choose to recreate real buildings in model form by first studying, photographing and measuring the real thing. Scratch-built models like these can instantly evoke a period or specific location. Whilst this is perhaps beyond the reach of the outright beginner, there are plenty of shortcuts to help anyone who wants to gain experience of scratch building. You can buy embossed or moulded plastic sheets. They are simply cut to size and then glued onto the shell of a building or wall. But the best way to gain experience is to begin by using kits. Card kits usually have the detail printed on them. You begin by cutting all the wall sections from the main sheet. The window and door openings should also be trimmed out. You can work on one section of the building at a time. Fold back any tabs that have been provided for features such as door recesses and apply some glue. An all-purpose glue such as Bostik or UHU is used for card buildings. While the glue is setting, you can cut out the window frames, which are often supplied on acetate sheets. The previously glued tabs can then be stuck down and the windows glued in place. This kit is part of the Metcalf range, but the construction principles apply to most card kits. As each individual wall section is completed, it's added to the main structure of the model. As a finishing touch, using a felt tip pen to hide the non-printed areas where the card has been cut will improve the appearance of the building on the layout. There are also many plastic moulded kits to choose from. This example is a goods shed. Assembly is mainly a matter of joining the parts using plastic weld in much the same way as the platform we saw earlier. The goods shed is coming together, but like all plastic buildings, its appearance will be improved immensely through painting. The building can also be weathered. Here it is in position on our layout, with the subtle grimy look achieved by smudging a small amount of undiluted poster paint with a finger. All your models will look better if you add a back scene. The use of a Faller back scene has given an extra dimension to this layout. In this case, Pico ready-made back scenes have been employed. As well as docks, the range includes everything from towns to countryside. Frequently, modelers locate buildings along the back scene. These comprise only the frontage of the building and part of the sides and are known as low-relief models. In this case, scratch-built low-relief models have been blended with a hand-painted back scene, with Humbrol paints being used on both to ensure a good colour match. But as our layout shows, Pico back scenes and low-relief kit buildings also work well. The key to creative satisfaction comes from giving your layout its own unique personality, which means attention to detail. There is a wide range of accessories to choose from. On our layout, a few animals will add to the atmosphere. But you can use everything from lampposts to vehicles and figures to breathe character into a layout. Many layouts derive their charm from little cameo scenes like these. With so many products available, giving your layout that individual identity is as much about imagination as skill. Another area not to be overlooked is signalling. To begin with, most modelers add a few basic semaphore signals, such as starters at the end of platforms. For current railway practice, there are, of course, colour light signals. Our layout is now complete, at least for the time being. Eventually, most people want to try something different. So next, we'll look at some more advanced techniques. Our first layout showed how a train set can be developed into a full-blown model railway. But looking at other layouts shows that there are always higher standards to aim for. We're now going to look at some of the techniques that will help you go on to achieve these. Let's go back to basics and think about baseboards again. Layouts like this are built on more than one level. Here's the baseboard for this section of railway when it was under construction. Unlike our earlier layout, it's not built on a flat surface. The framework is largely exposed, with surfacing over the track carrying areas only. This is what is known as an open top baseboard. Plywood strips are pinned to the framework to provide a base. Piers to support gradients and elevated tracks are built up from the plywood using timber and sundealer. For curved sections, blocks of timber on the plywood base form a subframe, eliminating the need for jigsawing. Sundealer running surfaces are glued and pinned over the different subframes. You can see why open-top construction is ideal where multiple levels are required, since the height of individual track and road surfaces can be varied. The layout we're going to be working on, a smallish end-to-end configuration, also uses open-top construction, although in a simpler form. It's actually built on two baseboards, which can be separated when you want to move the layout. Which brings us to another new technique, baseboard joints. These fittings are made specially for the purpose by a firm called Red Dog, whose address can be found in Railway Modeller magazine. The brass lugs are fitted at the end of each board and ensure accurate alignment when the two sections are slotted together. The bolts, two of which are used for each joint, secure the two baseboards together and can be easily tightened by hand. The result is a neat join with no movement between the two boards. This time we're going to use Pico's Streamline flexible track, which permits curves of any radius. It's available in two standards, Universal, on which you can run any rolling stock, and Fine, where the rail tolerances are closer to the track found on real railways. As the Fine standard is really only suitable for very advanced modellers, we're going to use Universal, which is entirely compatible with SetTrack. As always, the first job is to mark up where the track will go. Next, we lay a base for the track. Flexible track can be laid using a similar foam inlay to that used with SetTrack, in which case there would be no need to make a base. But we've decided to go for granular ballast this time. Cork and other materials can be used for the base, but we're using balsa wood because it is light and easy to work with. The balsa is cut to match the track layout you've marked on the baseboard and glued into place with an impact adhesive. Now for laying the track itself. We'll start with the section over the baseboard join. Two tracks cross the join and brass screws are inserted on each side of the join in line with the underside of the rails. It's important that the rails make contact with the screws whilst remaining level, so the screw height must be carefully adjusted. Next, a gap is cut in the sleepers so that the track will fit over the brass screws. As the end of this track section is going to be joined to the turnout, the chairs, which hold the rails in place on the end sleeper, are cut off. When the two sections of track are pushed together, the rail joiners will be able to slide between the end sleeper and the bottom of the rail. Unlike SetTrack, with Streamline, rail joiners are supplied as a separate item to be fitted as the track is laid. In order for them to fit alongside each other, each of the two tracks that are being joined to a turnout will need to have the width of the sleepers reduced at the point where they meet. With the turnout joined to the adjacent tracks, everything should now be laid in position and a mark made to indicate where the motor will be connected to the turnout. Unlike before, when a larger rectangle was cut for the point motor, we were able to get away with a small hole. This is because this time we are using a different type of motor to operate the turnout. It connects to the tie bar with an extended pin. Allowing for the movement of the tie bar, the hole should be no less than 3/8 of an inch or 10 mm in diameter. The joined section of track can now be affixed to the track base using impact adhesive, applied longitudinally to the underside of the track and turnout. With the whole section now laid over the baseboard join, all the rails are soldered to the brass screws. Although soldering worries some people, it really is just a matter of practice. Once the solder has set, the rails can be cut. A Dremel is a useful tool for this. After cutting, the soldered rail ends will ensure that nothing moves, automatically giving perfect track alignment every time the baseboards are joined together. To finish off this section, some of the discarded sleepers are cut into short lengths, which are glued in place to give visual continuity over the baseboard join. The rest of the track work is laid using similar principles. You can see how an Exuron cutter is excellent for cutting rails without burrs. Bear in mind that where track is being curved, the inner rail will need to be cut a little shorter than the outer one, as its radius will naturally be smaller. If you lay the track in its final position before cutting, the amount of rail to be removed will become obvious. Now for the ballasting. Once all electrical wiring has been installed, granular ballast can be sprinkled around and between the sleepers. Any excess ballast should be brushed away to avoid unwanted particles getting into the mechanisms of locomotives. Using a container fitted with a spray nozzle, a fine film of water should be sprayed over the ballast. Then, using a small syringe, PVA glue diluted 50-50 with water can be accurately applied to ensure that the ballast sets hard. With groundwork completed, the layout is taking shape and is in full working order. But how do you carry the electrical current across that baseboard joint? One answer is to feed all wiring on each board to a multi-way connector. Then, irrespective of the number of wiring circuits to be joined, you have only one thing to plug in. Here's the finished layout, with all scenery built using the same methods as on our previous model. So much for building a model railway. What about operating it? Railway modelling encompasses a wide range of interests, but don't overlook the fun of operating your layout. As we said before, movement is an essential ingredient of a layout, and the way you achieve it can be as authentic as the models themselves. This layout by Adrian Full, for example, is based on a company in the Bristol area called Western Transport. The line itself is fictitious, but its operation is derived from real railway practice.
Well, the layout runs to a full 24-hour, 7-day-a-week timetable, with various trains running different days of the week as they would in reality. And then you sort of build the timetable up by having the regular frequency services in initially, and then adding to that various freight and passenger services, the odd ones through the day, and then working out the locomotive diagrams from that. And obviously then you've got to consider whether locomotives would need fuel or not, or whether they just need to be stabled up, parked out of the way in between trips. Western Transport is imagined to be quite a progressive company, and are quite willing to get any spot loads that come along. An example of that would be the big German ferry wagons, which are very impressive models, and that's assumed that brings steel in from Germany. So it's quite a progressive company, and that gives an opportunity to model various different types of trains depending on what model wagons are available. It's not really a timetable, but it's actually a schedule. And it just, whenever the whim takes me to operate the layout to relax for a few hours, then I'll operate as much or as little of the timetable as I get through. Operating the layout just for my own enjoyment tends to mean that I can have big gaps, as would reality be, between the trains. I might just admire the layout for a while, or read a book, or do a bit of modelling, whatever, and then come along for the next movement. So that way you get the busy periods and the quiet periods, trying to reflect reality.
As Adrian has found, an operating schedule, rather than a timetable as such, offers realistic workings whilst avoiding undue rigidity. You can make it as simple or as complex as you choose. Let's follow part of the schedule for the Truwheel layout at Picorama. In this case, each move is described on its own page, and the first requirement is to bring the passenger train in. Now the operator is being asked to bring 2 China clay wagons from the warehouse to the works sidings. You can see how, even with a small layout, the combination of a well-planned track arrangement and an interesting sequence can bring hours of pleasure. Now it's time for the passenger train to depart. Referring again to the schedule, we see that the China clay wagons have now been loaded and are ready to begin their journey. As Adrian has pointed out, the good thing about operating to a sequence of events is that you can stop whenever you want and pick it up again when you next have time available.
I think the operations are probably as important as the actual model making. Trying to get the correct formation of trains with regard to the correct continuity of brake types within the train, formation with brake van or not is required, getting the correct locomotive on, and also the correct operating practices. I think it's all very important to the realism of the layout.
With so many aspects to railway modelling, it's not surprising that people refer to it as the hobby of a lifetime.
I sort of went at it like a bull at a china shop, I think, and made quite a few errors and mistakes. But I've reached the point that I'm at, largely as a result of looking at the railway modeller, and hopefully you've got a long time to enjoy it, and there are a lot of different ways you can go.
Wherever your main interest lies, you'll find plenty to keep you occupied. So, why not get started now?